So today we're going ahead and starting the next unit, which is on trigonometry. We're going to review some things first. First of all, how to solve proportions. You must be able to solve proportions well to be able to do well in trigonometry. So this is pretty straightforward stuff, so we're going to blaze through it pretty quickly. So we want to solve each of the following to the nearest hundredth. Hundredth is how many decimal places? Two places behind the decimal. That's going to change depending on the problem. Some problems are going to ask you to round to the nearest tenth. Some are going to ask you to round to the nearest hundredth, some to the nearest thousandth. You have to know which is which. You will lose points every time you misround something. All right, so let me pull my calculator up. We'll do that later. Okay, so solving proportions. If you have a whole number equal to a fraction, make them both fractions. Step one. Step two, cross multiply. Sometimes it's really easy. X times 1 is just x, and 18 times 11, if you need your calculator for that, that's fine. That is 198. So we're just cross multiplying. Now, on the next one, notice the x is in the denominator, and that's going to happen sometimes. Here, when you cross multiply, you get 34x is equal to 87. And then what do we do to solve that? Divide by? Yeah, divide both sides by 34. That's going to be 2 point something. So 87 divided by 34 is 2.56, because it said the nearest hundredth, right? So when you're rounding to the nearest hundredth, you look at the hundredths place, and then you look at the place after that. If the place after the hundredths place is 5 or more, you add 1 to the hundredths place. If it's less than 5, then you just leave the number alone. So this is going to be 2.56. Sometimes you'll have other operators, like for example, the square root. We're still going to just put this over 1 and cross multiply. X is just going to be 9 times the square root of 73. And I'm going to put that into my calculator. 9 times the square root of 73. Now on this one, when we're rounding it, we look at the place after the hundredths place, which is a 6. So we're going to add 1 to the 9, making it 10. So this is 76.90. That's to the nearest hundredth. Again, sometimes what we want is in, sorry? On number 3, do you have to put the 0 on the number? You absolutely have to. And the reason you have to is because it says to the nearest hundredth, so you want to show the hundredths place is 0. Okay, that's a great question. It's going to come up on some of the problems. So yeah, if it's to the nearest hundredth, yes, you need to show the hundredths place. Thank you for asking. All right, for this one, same thing. We're going to put this over 1 so that we have fractions on both sides. So this is going to be the square root of 127x is equal to 43. and we'll divide both sides by the square root of 127. So on our calculator, we'll do 43 divided by the square root of 127. And that'll be 3.8 what? 2. That one's going to round up. All right, let's look at solving these last two. These last two, there's really no reason to cross multiply here. We just need to get the x by itself. How do I get rid of the squared? We've been doing this for months now. I'm sorry, someone said it, I think. Take the square root. And we need to take both the positive and the negative square root. So x is going to be equal to plus or minus. We're going to get two different answers. I'm going to take the square root of 423 divided by 18. And we get 4.85. Yes.
When you divide it, does like the whole thing have to be in the square root?
Yes. So depending on what version of the calculator you have, it will keep it underneath the square root until you move out of it, right? But we want to take the square root of the whole thing, right? So we want all of it to be underneath the square root. Now for this one, how do we get x by itself? How do we get rid of a square root? You do what? Divide by the square root of what? No. So here, the opposite of squared is square root. That's why we took the square root. So here, since the opposite of squared is square root, to get rid of the square root, what do? We're going to square both sides. So we're going to do, and you have to put the parentheses on this one, 34 divided by 110, close the parentheses, squared. And that's 0.10 to the nearest hundredth. So part of your homework tonight is just going to be practicing doing that. Hopefully you're already good at solving things like that. If not, this is a chance to practice and get better. All right. So now we're going to talk about trigonometric ratios. So, quick question for you. Why are triangle ABC and triangle XYZ in this picture similar to one another? So that is called, yeah, it's angle-angle similarity. Very good. So if I do AB to XY as BC is to what over here? YZ. We're just matching up the corresponding parts. Also remember that as long as I have the same cross products, that I have an equivalent proportion. So if I do AB over BC, What needs to go here so that I have the same cross products? XY over what? Someone's whispering it really loudly.
YZ.
Over YZ. So we're not saying these sides are equal to each other. We're saying the ratio of these sides is the same. Well, from the 23, in both cases, where is the part on top? The AB and the XY, where is it from the 23? What do we call that when it's all the way across the triangle? It's called opposite. So that's the opposite side over, what do we call BC and YZ in both those triangles? It's the hypotenuse. So even though these two triangles are not at all the same size, the ratio of the opposite side to the hypotenuse is the same because these two triangles are similar. And this is the basis for all of trigonometry. So this ratio of the side opposite an acute angle to the hypotenuse of the triangle is so incredibly useful that it has a name. It is called sine, S-I-N-E. There's a long and tortured history behind that name. It turns out that it was originally in Arabic, and when it got translated into Latin, someone translated it wrong. And then when they put it into English, we got stuck with it. And then, 200 years later, someone figured out that it was a mistranslation. And by that point, everyone was already using it. So they just left it. It should have been a completely different word, but don't worry about that. So here are some definitions that you need to memorize. And I don't ask you to memorize a ton of stuff. Most of the time I'm like, you just need to understand it. But here, if you do not memorize these, you will fail the test. There's just no two ways about it. So, in a right triangle, it must be a right triangle. If it's not a right triangle, you can't use any of this. With an acute angle A, the sine of A is equal to the ratio of the leg opposite angle A to the hypotenuse. Written in shorthand, this is still sine. Yes, I know it looks like the word sin, but it's an abbreviation. So it's not the sin of A. A didn't do anything wrong. A is not going to hell. Okay? It's the sine of A. The sine of A is equal to the opposite leg over the hypotenuse. Likewise, the cosine of angle A is the leg adjacent. What does adjacent mean? If something is adjacent to something else, where is it? It means it's next to. That's exactly right. Adjacent means next to. So we say the cosine of A, and again, please do not say the cos of A. That just makes you sound dumb. Okay? You don't read abbreviations. You say the word when you get to an abbreviation. So it's the cosine of A is equal to adjacent over hypotenuse. And finally, the tangent of angle A is equal to the leg opposite angle A over the leg adjacent to angle A. So tangent is opposite over adjacent. Now, for memorizing this, there are lots and lots and lots of different ways that you can memorize this. Personally, I think it's not so hard to just memorize. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Doesn't take that long if you just straight up memorize it. There are various sentences that people use to memorize this. I'll show you one, mostly because if you look it up on Google, how do I memorize trig functions, it's going to show you this one. I'll apologize in advance and hope that no one's offended by the drug reference in it. And it's this sentence. Some old hippie caught another hippie tripping on acid. If you take the first letters of all of those, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. If you want to memorize that, that's fine. Some people just memorize the letters. SOHCAHTOA, there's a really horrible story about some Indian chief with his wife's name was SOHCAHTOA or something. It's really kind of awful. My only problem with that is, I swear to you, this happened to me more than once. I had a student who would, during the test, raise their hand and say, I forgot how to spell SOHCAHTOA. And I'm like, well, then it's not really helpful to you, is it? Okay. So if you want to memorize that, that's fine. If that helps you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, that's fine. Whatever it is that it takes to help you. All right? He's just waiting for me to stop looking at him so he can do something. All right. So let's write the ratio for each of these. So the sine of r. So first of all, notice we have a right triangle. If we don't have a right triangle, none of this works. You have to learn other rules for things that are not right triangles, and you'll learn those when you get to pre-cal. All right, so the sine of r. Sine is opposite over hypotenuse. So from r, what's the length of the side opposite angle r? 12. And what's the length of the hypotenuse? 13. That's it. The sine of r is 12/13. All right, the cosine of r. Cosine means the adjacent leg. We usually just say adjacent, but it's the adjacent leg. And the reason we have to say that is because both the 5 and the 13 are next to the angle r, but only one of them is a leg. So it's going to be 5 over the hypotenuse, which is 13. The tangent of r will be the opposite leg over the adjacent leg. So from r, opposite is 12. The adjacent leg is 5. If you're going to whisper, at least get it right. All right, now let's go from angle T. From angle T, the sine of T is opposite over hypotenuse. Opposite angle T is what side? 5. And the hypotenuse is? Still 13. From T, what is the length of the adjacent leg? From T, adjacent leg is 12. And the hypotenuse is 13. So cosine is 12 over 13. And then the tangent of t, tangent is opposite over adjacent. So the opposite leg is from t, 5, and the adjacent leg is 12. All right. Sometimes instead of the name of the angle, sometimes you have the measure of the angle instead, but it works exactly the same way. So from the 26-degree angle, sine is what over what? Opposite over hypotenuse. So from the 26, the opposite leg is what? X. And the hypotenuse is 17. We want the tangent of 64. Tangent is what over what? Opposite over adjacent. Opposite the 64 is which side? 9. And the adjacent leg is x. There's two adjacent sides, but it has to be the adjacent leg. All right, tangent of 26. Tangent is what over what? Opposite over adjacent. So from the 26, opposite is x. Adjacent is 9. The cosine of 26. Cosine is what over what? Adjacent over hypotenuse. So from the 26, the adjacent leg is 9, and the hypotenuse is 17. The sine of 64, sine is what over what? Opposite over hypotenuse. So from the 64, opposite side is 9, and the hypotenuse is 17. And then one more, cosine of 64. Cosine is what over what? Adjacent over hypotenuse. Adjacent to the 64 is x. And the hypotenuse is 17. Any questions about that? We'll do more with this tomorrow in class.